Troutdale, Oregon Airport, home of the 50-mile-an-hour winds.
Really? Troutdale.
Yeah.
All right.
We selected that mainly because of its proximity to McMiniman's Edgefield.
All right.
4 and 7.
Sure.
4, 7, 7. I used to have that as a background on my phone because I couldn't figure out where the marks were. Yeah, so I'd just key my lock screen and be able to see like, okay, this is where the mark is. Zoomed in version.
The thing that's so wonderful about, well, one of the things that's so wonderful about it is how spacious it is in here. You know,
Yeah, so
it's a big van and plenty of room to...
yeah, I'm sure it's hard to tell from the signal that we stream out about the control vans, but they're really 3 20-foot shipping containers that have removable walls, and we've taken the walls out and we mate them together. So you're actually in one shipping container and the front row is in a different shipping container. So you could very easily pass these on the freeway and have, think it's full of gaskets or sprockets or something and not realize it's an ROV control going down the road.
So you could take it apart.
Yeah, we built it in Troutdale. We shipped it down to Mississippi. Then we shipped it to Mexico. It was put on this vessel.
So it comes in 3 parts and then you just put it all together. That's amazing.
Yeah.
Yeah, I can see now looking at it.
It can work on any vessel of convenience as well as the Nautilus.
Yeah, it's mobile.
It's nice.
The whole thing. We have about a dozen fiber optic cables. Each one has a dozen fibers within it. It's about 150 fibers that connect us to the rest of the boat. And we can disconnect those fibers and a handful of ROV cables and lift the whole thing off the boat, send it somewhere else.
And this beautiful vision that you're seeing in front of us, these screens, there are several places on the ship that people can sit and watch as well, so they don't have to pour into this control van and crowd it. They can sit in the library or down in the lab. And
one of our design principles
bridge
was that people should have the information they need where they need it and the ability to change what they're looking at. So we actually have 25 monitors that we feed, 11 of them here in the vans and 14 throughout the vessel.
Not to mention all the shoreside places you can.
Yeah, we have lots of places to connect to on shore. We can have remote participants open a web browser and be connected to our intercom and tell us exactly where they want a sample taken or an instrument placed. And we really leverage what's termed telepresence, which is the ability of remote participants to direct operations and participate in what we're doing without having to be physically here. In the old days, if we went out for a 30-day mission and one of those days was going to be spent at a maritime heritage site, somebody who's an expert in shipwrecks would have to take a of interest to them. They can do that from their office or
scientists on shore can sign up for that, and they can write in and help us out with identification or suggestions on sampling.
And we've also outfitted the entire system with 35 cameras, of which Bob only hates 2.
The ones that look at me.
It's difficult to get used to. If you're a professional and you're very good at what you do, to suddenly have the manner in which you do it broadcast to the world changes the workplace dynamic a little.
Yeah.
Yeah, there are privacy issues involved.
Yeah.
And you let us know where those cameras are, so.
Yeah,
we don't have
Yeah.
to.
But you don't know when they're going out to the world.
I usually will tell. I tell people if I'm going to use the pilot cam or the overhead.
Thank
It's
you.
very rare that I find if a pilot was trying to describe how they're using the manipulator parent, for example, that's a great time to use one of those other angles to show exactly what they're talking about.
Well, it's
That's
pretty.
interesting too, because I haven't thought about this before, but you know, our ROV pilots have a forward-looking camera, our Herc Zeus on channel 1, that they use for their primary vision, and then there's a brow or bubble camera above them to give them an overhead view. And in their mind's eye, they're able to synthesize a 3D view of what they're doing by combining those two sources. And in the same way, we have the ability for our viewers to show them a forward-looking camera of what the pilot's doing and an overhead camera looking down so they can actually see it in
And
2 axes.
And the pilots make it look so easy, but yeah, they're basically, you know, that brow cam helps make it more 3-dimensional.
Right. And
But you're doing 3-dimensional work in a kind of a 2-dimensional space, and they make it look easy, but it's not. Although,
yeah, and you can't really tell it from our website, but the pilots are monitoring 18 or video sources right now, and 3, 4, 5, 6, 7, 8 computer monitors.
yeah,
At least I hope they are.
Constantly scanning. Speaking of which, we're about 400 meters off the bottom.
getting close.
Thank you for that.
I've been watching. Quick math.
1,200 plus 400 is 1,600.
We need that little double ding, you know, like when an aircraft goes below 10,000 feet. Ding, ding.
Pull up.
You know, not that ding. We don't need that ding. Whoop, whoop. Stick shaker. Just like when we got within 300
I put one of those on Jason, though.
Yeah?
Alarm, yeah. Depth triggered
Yeah.
alarm. Yeah.
If depth is less than X and
Yeah.
descent